I hope you have seen the syllabus. Did you? Did you all check with the syllabus?
Yes, ma'am.
Yes or no?
Yes, ma'am.
Yes. So, which is the first chapter?
Electrochemistry.
Electrochemistry. Correct. Electrochemistry and batteries. And it's important for us to discuss this in little detail. Why? It's because now with the advent of e-vehicles, okay, uh, the automobile industry is now dictated by the innovations in this sector, particularly batteries being used as the fuel. Now we want to replace all the automobile industry with the uh, fuel batteries as the fuel. Okay, so the know-how is very important, and we shall slowly start with the concepts of the electrochemistry. All this you might have really studied well in your intermediate and for your MSET and all. Let us do a small recapitulation and just go into the applications, that is batteries, and study few batteries, whatever they are there in the syllabus. Okay. So, by the way, you know which is the first company to start with e-vehicles? I'll go from top down.
Tesla, ma'am.
Uh, Tesla is the company. Uh, Elon Musk, correct?
Elon.
Yes, Elon Musk is the first person to bring in the e-vehicles. Now it is so very diversified that yeah, nowadays we are finding instead of petrol bunks, we are finding e-charging
Charge point.
vehicles. That's an upcoming sector. Huh? That's an upcoming one. Okay, and now in fact they are targeting the fastest recharging of the vehicles. Okay, how fast the batteries are going to be recharged is the demand of the day. Okay, and now by this time many of you might have already started using. In our country, of course, Tesla has not made that broad routes, but then we have so many inbuilt. Our industry is aiming towards making e-vehicles. That has come up really in a big way, particularly the mediums
Tata.
and small scale sectors are using e-vehicles nowadays. Okay, that's a happening one for us. One is manufacturing of the e-vehicles, complete the body designing, etc. And of course, the next one is the charging points for these e-vehicles. Everything is an upcoming sector. Okay, we shall learn about the applications at the last, but let us do a fast recapitulation of what all you have studied in your intermediate. Okay, starting with the topic electrochemistry and batteries. Please do write. I request all of you to maintain notes. Why? It's like don't write running notes, not necessary with my lecture. Because every time, even I'm like a student, I'll take a pause. I'll try to first tell or first listen, then recapitulate what all I have heard or told in a uh, line format. Okay. So you need not have to write running notes. Just listen to my lecture uh, with concentration. Then we shall just make few flow charts or any chart sort of a thing. Why? To give a browse. Okay. Anyways, you can have notes on hand. It's no big deal nowadays. Okay. But when you want to have a quick recapitulation, that flow chart should be written by us. Okay. So I request every one of you to maintain separate books, or the notes should be at a single place. Please do not make all in one spectrum notebook. That period after period you keep writing in the same old book. It's a wrong habit. We should not develop at any cost. That's it. no option but for maintain separate notes for each of the subjects. Okay, like these are some few important toolkits you need to know to be a budding engineer. Okay, that engineering spirit should be there in the way you do your work. Okay, so write the heading electrochemistry and batteries. Okay, so the heading for the session is electrochemistry and batteries, and usually I request most of my students to put dates on the right hand side corner. A good habit. How many a times I forget, but someone reminds me. I really love to do it, but most of the time I do it. Why? It has become a habit. My teachers taught me, so I'd like to bring in my students with the same idea. It should go very quickly with us. So today is 30th, 27th. What's the date?
27.
27.
27.
Okay, 27th. Now tell me, why sometimes when I browse my good old notes, I'd be just thinking, these notes I've written long way back, many years back. Okay, a sort of a nostalgic feeling. I'll get back to whatever I want to say. So, hope you know how the materials are classified. Classification of materials with respect to flow of charge. Okay, will all the materials allow charge to flow? No.
Conductors, insulators.
Okay, so not all materials allow charge or current to flow. Okay, so the materials which allow current to pass through them are called conductors, which do not allow current to pass through them are called insulators, and materials under activated or special conditions which allow the current to pass through them, acting as conducting materials, are called as semiconductors. Okay, and probably you might have studied about the superconductors. Did you? Messner effect and all. Did you
Yes,
study? Is it there in your physics first
physics.
sem one?
Yes, ma'am.
Yes.
Yes, ma'am.
Superconducting materials, Messner 1 and Messner 2 effects. Is it there?
Yes, ma'am.
Messner effect. What's the application of Messner effect?
Messner effect is there.
What is the application?
When a magnetic field is applied, when an object is placed in a magnetic field, the lines passing through,
It acts like a.
the lines won't pass through it, ma'am.
Okay. What's the application? Maglevs. Okay. Magnetic trains, where there's absolutely most the fastest moving trains. There's no contact between the wheels and the train track, because of the magnetic field. Okay, zero friction. That's the application. Okay, so that's a classification. But then why I'm asking you all these questions? Why this? Why classification of materials into conductors, semiconductors, insulators, and superconducting materials? We need to know in electrochemistry chapter. As the name tells, electrochemistry is that branch of science, okay, or chemistry, in which we talk about the interconversion of chemical energy into electrical energy and vice versa. Okay, so it's the discussion. Okay, ఏం చెప్తున్నా ఎలక్ట్రోకెమిస్ట్రీ చాప్టర్ లో దేని గురించి మాట్లాడతాము అంటే ఇంటర్ కన్వర్షన్ ఆఫ్ టూ ఎనర్జీస్ గురించి మాట్లాడతాం. ఒకటేంటి కన్వర్షన్ ఆఫ్ ఎలక్ట్రికల్ ఎనర్జీ ఇంటూ కెమికల్ ఎనర్జీ అండ్ కెమికల్ ఎనర్జీ ఇంటూ ఎలక్ట్రికల్ ఎనర్జీ. ఈ రెండు కాన్సెప్ట్స్ ని మనము ఈ చాప్టర్ లో చదువుతాం. కాబట్టి ఎలక్ట్రోకెమిస్ట్రీ చాప్టర్ లో మనకి ఫస్ట్ బేసిక్ ఐడియా ఆఫ్ మటీరియల్స్ కావాలి. ఓకే, So, in fact, when you're talking about the whole chemistry syllabus that is being included to you, you're always focusing on one point very clearly. That is the material science aspect of any concept. Okay, when you're talking about materials, their applications and their behaviors under different conditions, then you're talking about the chemistry of it. Okay, and this is what we are exactly going to talk in this chapter. So I was just trying to tell you that there are materials which allow the current to pass through them, and there are the other set of materials to the extreme, that side of the end, which do not allow the current to pass through them. Conductors and insulators. Okay, and in this particular chapter, we're talking about the chemistry of conducting materials, that too solutions, and hence the electrochemistry chapter. Okay, so what's the first definition we are going to write? What's the first point? Right. Point one. Electrochemistry. Electrochemistry deals with electrochemistry deals with interconversion of chemical energy to electrical energy, chemical energy to electrical energy, and vice versa. Okay, then I think that's what exactly I've told you. Is this what I've told you? Correct? Please do write this. Did I tell this? I think this is the first point. Okay. Point number one. So, what's the second point we have just now discussed? Okay. Second point, what we have discussed? Classification of materials. Classification of materials depending on their ability, depending upon their ability to conduct current. Classification of materials depending on their ability to conduct current. Is it not? That's the second point we have discussed. Okay. Did you all write? Are you catching up with me? Okay. So that's the second point. So materials are of how many types? 4 types. Main are the conductors, semiconductors, insulators, and superconductors. All this you might have already studied. Appears like as if you know them, but then why we always keep writing like this is for the viva voce session. Now, this electrochemistry chapter is the best one for your lab viva. That's it. There's nothing else for me to tell. Why we need to write all these flow charts. Keep on writing, keep on writing. Why is because, again, I tell you. See, external examiners, because you have a very small scope for your experimentation because of this, I might ask you questions from theory, and they expect you to answer it very diligently because these are certain things which is physical chemistry exactly. Physics also you might have studied lots about the semiconducting materials. Okay, so you need to be really confident about it. Now, what are conductors? You should raise your hands. You should be interactive. What are conductors? Quick.
Which conduct electricity.
What are huh?
Which conduct
Which allows
electricity.
the flow of charge.
Huh?
Which have zero resistance.
Substances which allow current to pass are called as conductors. Correct.
Which have
What
zero
is current?
resistance.
Huh?
Which have no
Without
resistance.
which have
Negligible
less resistance.
like negligible.
Less resistance. There will be resistance always. There will be always resistance. We'll just talk about it. Just it's an interesting thing. You can just we can talk discuss. So materials which allow the current to pass through them are called as conductors. Now, what is current?
Flow of charges
Flow of
What
or
is
charge.
flow of electrons.
flow?
Flow of electrons.
Flow of. What's the difference between conductance and current? What's the difference between
Conductance is the ability of flow of current, ma'am. Current means flow of charges.
Conductor is a type which follows conductance.
uh, shall I put like this? Conductance is nothing but flow of charge. Flow of charge per unit time is called as current. Correct? What are the units of current?
Ampere.
Ampere.
Amperes. Amperes. So coulombs per second. Okay, how much current is passing through a unit time is called as current. And the total amount of charge that is flowing is called as conductance. Okay, what is conductance? It is nothing but the flow of charge through a substance. Okay, and uh, per unit time, if it is measured, it is called as current. Okay. Okay. How many types of conductors?
2 types.
How can I? What are they?
Superconductors,
Solid and liquid.
semiconductors is
Okay, then I'll ask you a question. We do electrical wiring in our houses? Fine. So, what in wires is conducting current? You have batteries? Batteries in your car, your mobile batteries, lead acid battery, lithium ion batteries. By the way, the batteries in our mobiles, laptops
Lithium ion.
are all are lithium ion batteries. Okay. So is it it's also a conducting material? And our electrical wires are also conducting materials. Are they same or different?
different.
Different.
Material is- In lithium ion batteries, lithium ions are present, but in wires, copper.
Okay. You're talking about the different material with which they are made of.
Yes, ma'am.
But then, is that the answer? And I expect everyone of March up to now. like everyone in the class should actively participate. Why? It's because absolutely I don't know what you're doing on the other end. It's like as if I'm just looking at my laptop or my computer or the wall there, and I'm just imagining you. I don't know that there are students on the other side, and I'm just giving all my lecture, trying to be more and more, give maximum of my expertise on the topic. What a nonsense it is. If you raise your hands, if you say yes or no, only then that interaction huh? So I don't expect only 2 spokespeople in the class. I expect every one of you should interact. ఏంటి 52 స్టూడెంట్స్ ఉన్నారు క్లాస్ లో, ఇద్దరు ఇంకోటి నేను, of course non-stop talking person in the session. Are we 3 there, or many of you are there, or you're just waiting for the notes that I'm going to give? ఏంటి difference? You're there in the class? Others, raise your hand first. How many of you are there? అదే నువ్వు నేనే. Let me check. How many of you are raising hands? The rest all are sleeping. Huh? I'll take you to task. ఏం తతుమ వాళ్ళంతా ఏం చేస్తున్నారు? Okay. It's not to scare you, but tell you that your discipline is against your decency, not my authority. Get it? I'll get back. Antena? Can your friends be edited? Can anyone classify conductors into how many types? Conductors classification is into how many types? Okay. Into 2 types. One is electronic or metallic conductors. The other one is electrolytic or ionic conductors. That's a classification of conductors. అర్థమైందా? అంటే ఏంటి? సరే, మెటీరియల్స్ ఉన్నాయి, అవి కరెంట్ కండక్ట్ చేస్తున్నాయని చెప్తున్నా. ఆ కరెంట్ అంటే ఏంటి? ఫ్లో ఆఫ్ చార్జ్. సో కొన్ని ఆస్పెక్ట్స్ మీకు అన్ని తెలుసు. సో దానిని ఎవరైనా క్వశ్చన్ అడిగినప్పుడు నీ బ్రెయిన్ క్విక్ గా యాక్ట్ చేయాలి అంటే దాన్ని రీఆర్గనైజ్ చేసుకోవాలి. ఎలాగా? ఇట్ ఈస్ ఇండివిజువల్. సో ఏవైతే కరెంట్ ని అలౌ చేస్తున్నాయో వాటిని అన్నిటిని కండక్టర్స్ అంటున్నాను. కరెంట్ అంటే ఫ్లో ఆఫ్ చార్జ్ పర్ యూనిట్ టైం. ఓకే, సో చార్జ్ ఫ్లో అవుతున్నది యూనిట్ టైం లో మెజర్ చేసి కరెంట్ అంటున్నా. సో కండక్టర్స్ అంటున్నా. సరే, నేను చాలా కండక్టర్స్ ని యూస్ చేస్తున్నాను డే టు డే లైఫ్ లో. ఇప్పుడు లెక్చర్స్ వినేదంతా మన ల్యాప్టాప్స్ ఆర్ బ్యాటరీస్. ఇంకోటి అసలు కరెంట్ లేకపోతే క్వశ్చనే లేదు. మన లైఫ్ ఒక నిమిషం కరెంట్ పోయిందంటే ఎలక్ట్రిసిటీ డిపార్ట్మెంట్ నానా తిట్టుకుంటూ ఇన్వర్టర్స్ ఆన్ చేసేసి హడావుడి పడిపోతాం. సో అన్నిట్లో కండక్టింగ్ మెటీరియల్స్ గురించే మన డిస్కషన్ అంతా. ఎలక్ట్రోకెమిస్ట్రీ చాప్టర్ లో కూడా అంతే, కండక్టింగ్ మెటీరియల్స్ గురించే the whole concept of discussion. సరే, నా క్వశ్చన్ ఏంటి? కండక్టింగ్ మెటీరియల్స్ అన్నీ ఒకటే కాదు, తెలిసిపోయింది. ఏవైతే నేను బ్యాటరీస్ యూస్ చేస్తున్నానో అవి కండక్టింగ్ మెటీరియల్సే. సరే, నేను ఇంట్లో యూస్ చేసే వైర్స్, వైరింగ్ ఎక్విప్మెంట్స్, ఎలక్ట్రానిక్ గ్యాడ్జెట్స్ ఏవైతే అంతా వాడుతున్నానో, ఓకే, ఏసీ పవర్ సప్లై అంతా కూడా అయ్యేదంతా వైర్స్. సో కండక్టర్స్ ని ఎన్ని విధాలుగా క్లాసిఫై చేసి నేను నేర్చుకుంటున్నాను అంటే 2 types. So conductors are of 2 types. One is the metallic conductors or electronic conductors because they conduct current with the help of electrons, and the other one is electrolytic conductors or ionic conductors which conduct current due to movement of ions to oppositely charged electrons. Okay, so ions are the charge carriers in the second case, and in the first case, electrons are the charge carriers, and hence is the classification. So, third point which I am expecting you to write is, what's the point, please? Is it the third point I'm writing? Okay, so the third point which I'm discussing with you is conductors. Conductors are of two types. What's the first one? Metallic or electronic conductors. Metallic or electronic conductors. That's the first one. And the other one is ionic or electrolytic conductors. Okay. So ionic or electrolytic conductors. The other one is metallic or electronic conductors. Okay, that's a classification. And I know most of you might be knowing about these things. You might have already studied this. Okay, but this is the classification. You know it, but when question is asked, the ease with which you answer shows that you're having clarity. That's it. It's all about keeping the clarity on what we are learning. So that's the other one. So now in this topic, we are interested about the ionic or electrolytic conductors. Now, what's the difference? You understood? What's the difference between metallic conductors and ionic conductors, or electronic conductors and electrolytic conductors? Can anyone tell me?
Charge of electrons and charge flow of electrons and flow of electrons.
What's the difference? So, ఒక కాపర్ వైర్ లో కరెంట్ పాస్ అయ్యేది, ఒక బ్యాటరీ లో చార్జ్ పాస్ అయ్యే కాన్సెప్ట్స్ రెండు సేమా డిఫరెంటా? ఫస్ట్ పాయింట్ డిఫరెంట్. అది అర్థమైపోయింది అంటే ఎస్ ప్లీజ్. సో ఇన్ డిఫరెంట్, ఓకే ఫైన్. సో నాకు అర్థమైంది ఏంటి, ఫ్లో ఆఫ్ చార్జ్ ఇన్ కాపర్ వైర్ and the battery that I am using, okay, which is also a conducting material. In both the cases, there is always current, but how they are being used, or what's the materials and what's the concept of the charge and current is different. So the classification. So I'll ask you one point. In metallic or electronic conductors, which will conduct current? Electrons will conduct
Electrons.
sorry. Okay. Whereas in ionic or electrolytic conductors, the ions are conducting current. Okay. Fine. Then I have to ask you, a copper wire is there, and I'm just holding that copper wire in my hand. There is no shock. You're saying copper will conduct current. Then my question is, why not the copper wire under normal conditions is not giving me a shock, whereas as soon as I plug it, it's going to just give a huge shock? Why?
The algebraic sum of
There is no
movement of
movement of
charges is
electrons,
zero.
no ma'am.
We
Why
need a
is
potential
it?
difference
There,
for
but
it.
equal in opposite direction.
Equal and opposite direction. Asal, why there is no flow of charge? Enduku flow of
We need a
charge?
Flow of electrons
potential
there, ma'am.
difference.
Yes, exactly. For flow of charge, what is the basic requirement? Or
Potential
when the
difference.
charge will, yes, that's it. That's the first
Charge will
point.
move.
Ma?
Electrons will move when potential difference is not applied also, ma'am, inside conductor.
Not applied. Potential difference should be created somehow. అంతేనా? సో ఎప్పుడైనా చార్జ్ ఫ్లో అనేది ఎప్పుడు వస్తుంది? Then there is a potential difference. Okay. So in both the cases, okay, there should always be potential difference. Now I'll come to my point. So conductors are materials which allow the current to pass through them. Okay. And there is always flow of charge when there is potential difference. Okay. And I'll get back to my concept. Now, whenever there is a potential difference, charge will flow in the form of electrons in metals and in the form of ions in the case of electrolytes. Okay. Now, nowadays, we can't say the first one as solid conductors, the other one as liquid conductors. Obviously, the lithium ion batteries, whatever we are using, we have solid electrolytes. Hope you know that. These are solid electrolytes. Okay. Tell me, Harsha, why did you raise your hand? Okay. So nowadays we are not classifying on the physical stage. Okay. But the carriers, charge carriers. In the first case, electrons are the charge carriers, and in the second case, ions are the charge carriers. And hence is the classification of the conductors. Okay. That means in a copper wire, electrons are always there, but the flow of electrons is because when you apply, when there's a potential gradient. Okay. When as soon as you give a potential gradient, the charge moves from higher gradient to the lower ones. Okay. And so in the case of electrolytes, in electrolytes, electrolytes are solutions or substances containing ions which can conduct current. Okay. Because ions are the charge carriers, the type of conductance is called as ionic conductance. And hence is the difference and the classification of materials. And what we should remember is that both metallic and ionic conductors obey Ohm's law. Okay, that's an important point to be remembered. That means in this chapter, we are talking about the ionic conductance and the materials having ionic conductance, that is particularly electrolytes, which obey Ohm's law. Okay. So, is the third point. Now, does anyone has any point to tell me now? Okay. So, can I make the fourth point like this for my quick recapitulation? The differences between metallic conductors and electrolytic conductors. Electrolytic conductors and metallic conductors. The difference is going to be interesting. That will help give some clarity of what all I was trying to tell you here. Okay. So what's the first difference? What's the first difference in metallic and electrolytic conductors?
Electrolytic conductors, as we increase temperature, conductance increases.
No, what the first point in really now.
Flow of electrons in metallic conductors.
Ikkada
Charge carriers.
Flow of electrons.
Ikkada ions are charge carriers.
Ion.
Yeah. At this point of time, I'd like to tell you one more important thing as a teacher. See, ability to express with clarity is a very good art. Ante enti? You might be having lot of knowledge. It's a common experience for us that we know few people are very intellectuals, but then when they are speaking, the other person will not get clarity. But there are some mediocre knowledge people, but whenever they speak, they have that ability to express completely whatever is there in their head. సో ఇక్కడ పాయింట్ ఏంటంటే నాలెడ్జ్ కాదు, ఎక్స్ప్రెషన్. అంటే ఏంటి, నువ్వు చెప్పాలనుకున్నది క్లియర్ కట్ గా చెప్పడం. ఓకే, సో ఇక్కడ పాయింట్ ఏంటంటే యువర్ ఎక్స్ప్రెషన్ టు రైట్ థింగ్స్. ఓకే, దట్స్ రీజన్ వై ఐఎమ్ జస్ట్ మేకింగ్ యూ రైట్ నోట్స్ లైక్ దిస్ యాజ్ స్మాల్ ఫ్లో చార్ట్స్. ఎందుకు అంటే ఏదో చెప్పాలనుకున్నావు, అది క్లారిటీతో చెప్పగలగాలి. ఫస్ట్ పాయింట్ ఏం రాయాలి, అసలు ఇవంటే ఏంటి అని రాయాలి. సో మెటాలిక్ కండక్టర్స్ లో పాయింట్ ఏ, electrons are charge carriers. Okay, right. A, electrons are charge carriers. Ikkada A, ions are charge carriers. A, electrons are charge carriers. Here, ions are charge carriers. Ante enti, under a potential gradient, here electrons are moving, here ions are moving. So ions are charge carriers. Ions are charge carriers. And sorry, how I am getting this, because I have been doing this repeatedly. To get confidence on any topic, when you just do this homework twice or thrice. Then the second point, B. What's the next point you can write? What's the next point you can write? Here electrons, here ions. What's the next point you can write? No, you don't want to tell. Okay. Now, is there any degradation of the material when current is passed in metallic conductors? And copper wires
No.
or any wires, do they suffer in there any change in the chemical composition when charge is passing? No.
No chemical change.
Yes. In this electrolytic conductors, there is change in the chemical composition of the material. So that is the second point I want to write. Okay, right. The second point here, no change in chemical composition. No change in chemical composition. Okay, here what you are going to write. B. Electrolytes decompose. Electrolytes decompose on passing current. So electrolytes decompose. That is, there is change in chemical composition. Okay.
And physical also.
Endama?
Physical change.
Physical change. Ade. Composition ante ante. Change mottam. Physical and chemical rendu. Next. What is the behavior of conductors, particularly metallic conductors? What will happen to the resistance on increasing temperature? ఏమవుతుంది?
Conductivity decreases.
Huh? Yes, please.
Resistance increases.
Resistance increases in the case of
Metallic.
metallic conductor.
Electrolytic.
No.
Metallic.
Metallic. What will happen to electrolytic conductors? I'll tell.
Resistance decrease.
Say the main difference between metallic and electrolytic conductors is its behavior towards temperature. With increase in temperature, metallic conductors resistance increases, whereas electrolytic conductors resistance decreases. Or I will explain like this. With increase in temperature, conductance of metallic conductors decreases, whereas electrolytic conductors increases. Why? Why is because if you are increasing temperature, the randomness of electrons increases. Therefore, the metallic conductance decreases. But if you're talking about the electrolytic conductors, in this case, the dissociation increases. Along with that, the speed of ions increases with temperature, and hence the conductance increases. So it is exactly opposite. So what you are going to say in point C? The temperature increases electrolytic conductance, whereas decreases the metallic conductance. Why? The randomness of electrons increases with increase in temperature. Therefore, metallic conductance decreases actually. Whereas the speed of ions increases and the number of ions also increase in the case of undissociated ions or molecules. In such cases, what will happen? The electrolytic conductance increases. It is exactly the opposite. So that is going to be part C. So what is part C? Point C, sorry. Temperature decreases metallic conductance. Temperature decreases metallic conductance. Here, temperature increases metallic conductance. Temperature increases metallic conductance. That's the next point. Okay.
Ma'am, ionic conductance or metallic conductance?
Enana?
Ionic conductance or metallic conductance? No? Temperature increases.
Temperature decreases metallic conductance. Temperature, ionic conductance. Sorry, really sorry. Correct. Increases ionic conductance. Thank you. Okay. So, but one point is common for both the things. Both metallic and ionic conductors obey Ohm's law. That's the last common point. So, point number 5, you write it as point number 5, not as a difference. Both metallic and ionic conductors obey Ohm's law. Okay. Both metallic and ionic conductors obey Ohm's law. Correct. Now, I have to tell you one point here. So, I tell you, it is impossible to find any material which does not offer resistance. Why? See, it's very simple. If you were to imagine, okay, easiest one is metallic conductor. Okay, what is happening in metallic conductance? Under a potential gradient, electrons are moving from one end to the other end of a wire, metallic wire. So when electrons are moving, they are in fact having repulsive forces with the other electrons. Okay, while they are passing through the atoms of that material. So is the resistance. And the resistance offered by any material is characteristic property of that material individually. Okay, so this is an important point you need to understand and remember. That means no matter how best we aim, we can always say there is always a minimum and more inductance. Okay, but it is an ideal condition not to have any resistance towards charge or current. Why? We can't expect that. Because obviously when there is flow of charge, there are always repulsive forces that are existing between the like charges. And hence every material offers resistance and is characteristic of that particular material. Okay, that's the point which I want to tell you. అంటే ఏంటి, సరే ఎలక్ట్రాన్స్ అవనివ్వండి, అయాన్స్ అవనివ్వండి, ఏవైనా సరే ప్రతి మెటీరియల్ కి రెసిస్టెన్స్ అనేది మ్యాండేటరీ. ఎంత రెసిస్టెన్స్ అనేది ఆ మెటీరియల్ ఒక వాటి క్యారెక్టరిస్టిక్. అంటే మెటీరియల్ కి అసలు ఎందుకు రెసిస్టెన్స్ ఎగ్జిస్ట్ అవుతుంది అంటే సింపుల్ లాజిక్ ఏమిటి, ఇప్పుడు చార్జ్ ఫ్లో అయినా అయాన్స్ ఫ్లో అయినా రెండు కండిషన్స్ లో ఎప్పుడు ఏముంటుంది, లైక్ చార్జెస్ నుంచి రిపల్షన్ ఉంటుంది కాబట్టి ఖచ్చితంగా రెసిస్టెన్స్ ఉంటుంది. అప్పుడు how can I define Ohm's law? No, define Ohm's law, kids. This is what you might have studied already. Define Ohm's law. Easy one. What is Ohm's law?
The current passing in conductor is directly proportional to the potential
Relationship
difference
between voltage,
between
current,
2 points in a conductor.
ఏదో గ్రూప్ ఆన్సర్ సూపర్. ఏంటి Ohm's law? I think sorry, I forgot that you are
In a circuit,
Chaitanya
the potential
Narayana
difference
student.
between any 2 points is directly proportional to the current passing through it.
ఏంటంటే
In a circuit, the potential difference between any 2 points is directly proportional to the current passing through it.
అది ఇంకా రివర్స్ ఇంకా బాగా చెప్పాలి అంటే
Linear
is directly proportional to the potential difference కదా. అదంతేనా? Ohm's law is only up to it.
linear relation between voltage and current.
Okay, your friend is telling. What, girl? Amma, tell me.
Directly proportional to potential difference and inversely proportional to resistance.
Amma. Okay. Right. Kirti has concluded the idea. So what's the formula now for Ohm's law? Formula చెప్పండి. మీ favorite కదా.
V is equal to IR.
V equals to IR.
V is equal to IR.
Correct. What, Teja? Why did you raise your hand? ఏదో నిద్రపోతుంది, ఏదో టకామని నొక్కావు. Stupid boy. Wake up. Okay. So, why I'm talking about all these things is it's like in which way I can talk about the electrochemistry topic with respect to Ohm's law. That's what is exactly what I want to tell you down the lane. Sare? So if I were to talk about the Ohm's law, okay, it gives what the Ohm's law gives. It's a relation between the amount of current passing through a substance and the potential difference and the resistance. So we can conclude that as V is equal to IR, where V is the potential difference, I is the amount of current that is passing, and R is the resistance offered by the material. Now this Ohm's law, this formula, whatever we were talking, is actually for metallic conductors, okay, or electronic conductors. So when I'm talking about the electrolytic conductance or the electrolytic conductors, the Ohm's law takes a new formula, okay, and hence is the discussion. So after understanding the concept till this point, okay, now I shall just pin on the main point, that is the electrolytic or ionic conductance, and I'll apply Ohm's law to it. Okay, so the sixth point here is straight away I'll hit at the concept. So what's going to be the sixth point? The sixth point is electrolytic or ionic conductance. The point which I shall keep on discussing in this chapter. So, electrolytic or ionic conductance is what exactly I shall keep talking in this whole chapter. Okay, so to understand this electrolytic or ionic conductance, I need to know few certain technical terms. Okay, so tomorrow, of course, we shall pin on the exact things of this chapter. So I shall stop my session with the heading under the sixth point, terms used in electrochemistry. Let me put this, I'm sorry. Terms used in electrochemistry. Okay. So what are the terms that are being very commonly used in this chapter, and with what ease we can understand the chapter is what exactly we'll talk tomorrow. Okay. So we shall give few definitions in such a way that it goes really easy for us to understand what exactly we want to tell in this chapter. Okay, so that's a small introduction to this topic. Okay, and not yet it's completed, just we are about to start our introduction. Okay, so let me take your attendance. Have one point to tell. I keep seeing many students joining. It might be a common thing for you, but then I have something to tell you. See, your attendance is not for roll call, yes or no, but your presence is for your interest. If not, you'll feel, I'm just telling you, you'll feel bored if you don't really concentrate on what you're doing. Okay, so answer your roll calls. 61.